Hey everyone, thank you for coming to the Multisim Live webinar. My name is Britt. I'm here with David and Edward. We're some of the team that has worked on and manages Multisim Live. So one of the reasons we wanted to do this webinar, back in 2020, Digilent was past management of Multisim Live, and we just kind of let it run, answer technical questions and made slight improvements here and there. But recently, we made some improvements, and we wanted to make sure that we put this out to folks that are at Digilent. So Multisim Live customers and Digilent customers have kind of been separate, but we thought this would be an awesome time for us to introduce this tool to Digilent users and kind of give a whole overview of it. So I've got Edward here on the call. Edward's one of the software engineers that has been working on it. And today we're just going to be going through a high-level overview of what Multisim Live is, what you can do in it, some of the collaboration and sharing tools, and different ways that you can create and simulate circuits. And with that, I'll pass it over to Edward. Edward, if you want to share your screen, and we can take it away.
Thanks, Brad. Let me share it. That's my webcam. Look at my. Let me just share the browser. So, can you see my screen now?
Yes, we've got you.
Oh, okay, that's lovely. So, Multisim Live is a browser-based online SPI simulator, right? And this is basically an introduction to what it can do, right? So, let's get started. From the home page, you can go to this Create Circuit button. That will start the editor. Let's see. So this is the interface. As you can see, I have, so this is the schematic editor, and here are the components, right, which is the emphasis of this application, right? So I have components for analysis, right? So basically voltage probe, current probes, digital probes, and so on, right? I also have connectors like ground connectors and junctions. You, of course, have sources for AC voltage, AC current, clock voltage, and so on, right? DC voltage, noise, whatever you'd like. So maybe you're looking for something specific, right? You can go here and search whatever you'd like, right? And that will help you get started even easier. You have op amps. You also have 555 timers, right, which are nice. Current sensing amplifiers, audio amplifiers, and whatever you can think of. You have diodes, transistors, interactive components, right? So indicators like lamps, LEDs, LED bars, buzzers, right? So since this is connected to the browser, it will actually buzz, right? So that's nice. You have switches, modeling blocks, like so voltage multipliers, divider, if you want to basically describe something more theoretical, right? So voltage controlled voltage sources and so on. You also have electromechanical components, right? So maybe you want to connect to, let's say, a motor, right? So you have a motor with that is brushless, or right? So depending on the type of components that you want to simulate. You also have power components like PWM controllers, right? So you can generate a pulse width modulated signal, right? You have linear regulators, switching regulators, and so on. And at last, we have digital components as well, right? So that's nice, right? So we have all of these components, right? So what are we doing with them? So to select one, let's say I want a resistor. I click on it, and then I'm able to place it onto the schematic, right? So for starters, let's get a simple register voltage circuit. So I get my direct current source, I place it as well, and now I can connect them, right? Which is nice. I click on the terminals and then I connect whichever component I want, right? So let's also add a ground to the circuit, right? And now I can also interact with the component. So for example, I can change like how the circuit, what the resistance of the resistor is, right? The temperature and so on. The same for the voltage source. And also I can interact with the simulation, right? So after I create a circuit, I may also want to simulate it. And here you can also find the overall settings, let's say. So I've created the circuit and I want to simulate it. So what I can do is I can select from the analysis and annotation window different probes, right? So let me select the voltage probe. And this by default is going to do a reference to ground. But I can also click on the signal, on this symbol, and manually add the reference, right? So after I'm doing that, I can simulate it, right? So how do I do that? I can select my simulation from here. I will select interactive for now, and I just click on it, right? So as you can see, the voltage across the resistor is 5 volts, which is what we expected. I can also see this data in the grapher window, right? So here I can see that the voltage is 5 volts. In the split window, I can see both of them. So what's nice about the interactive simulation is that I can schematic interact with the circuit as it's being simulated. So let's also, besides this, add a switch. I'll just add this here. Right, so I'm starting the simulation again, but this time with the circuit being disconnected. Let me take a look at the simulation. So let me go. So as you can see, I can interact with the switch as it runs. So you can see that the voltage, which is now 5, due to the circuit being connected, goes down to 0. That's much better. So as you can see, it keeps being in sync with what is actually happening inside the schematic, right? Which is nice. So inside the grapher, right? So I kept interacting with it. Now, and look at the entire simulation, right? Which, for how long it has been running, and just zoom on it, right? So this is the grapher interface, and I can, for example, take a look. I can zoom on every part, any part of the circuit, and see how the circuit interacted. So here I'm pressing the switch, for example, right? And I can zoom back out. Again, so let's also add an indicator, right? So this lamp. Multisim has these interactive components, right? So such as the switch or the lamp, right? So I'm connecting the circuit, and as you can see, the lamp is not turning on. That is because we're not providing enough voltage to it, right? So to do that, I can, let's say, interact with this source and go a bit further to 10 volts, right? Starting the simulation once again. And again, nothing happens. So, for example, we can also lower the resistance, right? And as you can see, it slightly dims, right? So it's from all the way to white, it goes to a slight yellow, right? So again, we can lower the resistance. So I can interact with this circuit as it runs, right? So I modify the resistance from 100 ohms, right, to 10 ohms. And as you can see, the lamp is drawing even more power, right? So the voltage across the resistor dropped and feeding in more current to it, right? So we go to 1 ohm, and as you can see, it's sort of fully lit, right? So another thing that I can modify is the actual voltage. So on the lamp, as you can see, it has a setting, right? So maximum rated voltage of 12 volts. And what will happen, and in the interactive simulation, I can change component values during the simulation. Right? So I move this to 12 volts, and if I change it to 13, right, it's red, right, it's heating up, let's say. We can see that we are actually providing too much power to the lamp, and it will eventually burn out. And so 16, 17, and the fuse has been blown, let's say, right? So it no longer has any light. It no longer emits any light. And so let's start the simulation. Let's also, so that's the interactive simulation, which is nice if you want to do, if you want to interact with the circuit in real time. Another type of simulation that it's interesting is the transient simulation. So instead of going on forever, the transient simulation will run for a set amount of time, right? So here I have it running for 1 millisecond. One interesting thing that we can do is we can add a capacitor to this circuit, right? So I can rotate this by going with by pressing Shift R, right? By using a shortcut, I can place it directly on the wire, and it will autocomplete. Right? And I also want to add another voltage probe right now across the capacitor. And what we've built is basically an RC circuit, right? So what happens if let's also lower this back to 5. So what happens when I run the transient simulation? It will simulate the circuit for exactly 1 millisecond. I can also update the simulator options, but I'm not. It's not necessarily. You're not really needing to interact with this. Maybe if you want the circuit to converge, but yeah. So this will run for 1 millisecond, and let's start the simulation and see what happens. Right, so we can see the voltage across the resistor is 5 volts, and this is 0 across the resistor. Why is that? So when we're doing transient simulation, we also have to check inside the capacitor model. If we click on this icon, we can get extra data about the component, right? So the IC is the initial condition of the capacitor, right? So in this case, this is the voltage across the capacitor at the start of the transient analysis, right? And we want this to start at 0, right? Because I want to see how the capacitor is charging. So if I run this again, it gives me the same result, but also a warning, right? So analysis initial condition are not set to user defined, but initial condition are set on the capacitor, right? So the circuit may not simulate as intended, which is correct, right? For transient, we also need to, instead of determining the conditions automatically, I want them to be user defined and to use my settings, because, for example, I may want to simulate how the capacitor charges with an initial charge already present, right? So instead of 0 volts, I may want 2.5 or something. Or maybe I want to see how it discharges, right? So let's run the transient analysis, right? And now there's something different. We can see, so if let me zoom on this. Right, I can see how the capacitor charges in real time and the voltage across the resistor drops, right? Let me go to this and also rerun this. Right, so depending on how you configure so in my, as you can see, it doesn't really start from, so the resistor voltage doesn't really drop from 5 volts, and this may be because there we go, due to how the time step is used. Right? So I can, let's say, change this to right, but these are settings that you can interact with. Right, so this is the transient analysis. Besides this, we also have a DC operating simulation. So what this does is it calculates the bias point in different locations of the circuit. So this is useful when dealing with transistors, for example. Right? So if I do this, instead of getting a graph, I get a table with the bias points in different parts of the circuit, right? So across the resistor and across the capacitor. We also have a DC sweep simulation, and what this does is it can vary a voltage source or a current source for different values. Right? So, for example, this one can it will rerun the simulation for different values. Right? So I can change this to, so it will run from 0 to 5, let's say, with 0.5 voltage increments, right? And if I start the simulation, right, so since this is since this is a pretty simple circuit, it will basically show us a linear relation, right? So it will just show me the voltage across the capacitor and the resistor. I can also do an AC sweep simulation, right? And this can show us, let's see, I can use it with either the DC voltage source or the AC voltage source, right? So in case I don't want to, right, I have already a circuit with this voltage source, I can also change these values, right? So I want an AC magnitude of 5 and a phase of 0, right? And this will run only for the AC analysis, right? And the DC voltage is used to interact with the actual interactive simulation and transient, right? So let me run the AC sweep simulation, right? So in the left side of the graph, I have the magnitude, and on the right side, I have the phase, right? And as you can see, the capacitor and the resistor are out of phase, right? These are the plots for this type of analysis. Since we have an RC circuit, right? This will be out of phase. The capacitor, which is in blue, and the resistor, which is in green, right? So the dash line is the phase, and the continuous line is the magnitude, right? I can also, for example, modify, let's say, the vertical scale, right? So instead of a logarithmic scale that it's used now, I can use a linear scale, but that won't really help us in this case, right? In the previous simulation, we used a linear scale, right? Since the data was easier to be expressed. Right, so you can also generate these plots using the AC sweep analysis. It's also use an AC voltage source. So I'll place this here, connect it, and I will delete the old one. Right, so again, if I click on this, I can modify the peak voltage. Let's place it back to 1. The phase will leave it to 0, and it will generate the same plot, right? Again, so if I simulate the circuit, what we have is basically a low-pass filter. To go to the split. And I can interact with the frequency in real time, right? So let's say if I divide this by 10, right? So you can interact with the circuit in real time. Right, so as you can see, as I increase the frequency, right, the voltage dropped on the across the capacitor. And right, so we went through these simulations, and the last one is the parameter sweep, right? So if I select it in the settings bar on the right side of the screen. For the parameter sweep, you can select different types of analysis, right? So transient AC sweep for the DC operating one, the DC operating point one. You can select a parameter from your circuit, right? So for example, I can select the capacitor and change either the capacitance or the initial voltage, but I want to modify the resistance, right? So I select the resistor and I select the resistance. And then what I can do is I can change the value, right? From, let's say, 10 to 100 ohms. So actually, let's go a bit higher. So let's go through. Yeah, I don't think I can see my mouse pointer, but oh, there it is. Nice. Let's go from 1K to 100,000 ohms. There we go. And I'll set, instead of increments, set the number of points. So I'll go with 10 points. There we go. And I can run the parameter sweep simulation, which will vary the resistance and redo the transient simulation, right? Oh, and I'll also need to remove the capacitor. In this case, let me connect and disconnect this. Yeah, since this reuses the transient analysis settings and this only runs for 1 millisecond, I'll also need to lower the frequency. The voltage source. Actually, let's see. Set back to determine automatically. Parameter sweep. Sweep type is linear. It's strange that the voltage is not changing. Yeah, let's run it longer. Right, so this is the transient analysis, and let's also do the parameter sweep. Interesting. So you should be able to see how the voltage changes with different resistances. So perhaps this is due to Firefox, but I'm not really sure. But yeah, either way. Now, Multisim is a mixed mode simulator, right? So I can, for example, integrate digital circuits directly into my schematic. So for example, I can get an AND gate. And I can connect to different constants, right? So let's say digital constant here as inputs. And I can, right? So I can connect any type of component to it, even an LED, right? So if the wire is blue, it means that the wire is digital, right? And it will hold values for zero logical, right? So for low and high. And for the logic levels, if you need to translate it to an analog signals, it will use the logic mode here, right? So you can change it to from 3.3 volts to 5 to a simplified version or your own thresholds, right? And what happens, let me go back to the interactive simulation. Let me add some digital probes and let me add a voltage here. And I can also change the color to whatever you'd like. So let's go with purple for this one, right? And if I run the simulation, since I have an AND gate with two logic ones connected to it, I go to the split simulation, right? So I can see my old circuit as well as the new logical constants, right? So here on the right side, I have the digital values, right? So either 0 or 1. So since this is an interactive circuit, right, as you can see, the LED has lit up. But if I turn this off, right, so I set the input to 0 and the AND gate turn the LED off, since it no longer provides an output value. Right, so the logical one has been translated to a 3.3 volt due to the logic level setting, which is found here, right? Right, so I could even take this and connect it to the old circuit. Let me change this from 3.3 to from 5 to 3.3. Let me zoom in. Right, so although this is a sinus signal, it will translate that to either 0 or 1 depending on the settings. Right, so let me lower the frequency to 1 Hertz, so we can expect the values on the right. So why this happens is that the voltage gets dropped. Let me move this from here to here. Right now you can see how the LED lights up, right? So it will translate that, and when it hits the peak, it will generate a 1, right? So you can also use some digital components like the digital clock, or you could connect, right? So this component, if you look for clocking signals, right? So for square signals, let me go to 1 Hertz, right? So right, you can see depending on how the simulation is set up, the simulation step is quite high, right? So in this case, it keeps, it's not really in real time, right? So I turn this off and you no longer see the value, but you could still see them inside the grapher. Good. Right, you also have pulse voltage if you want to experiment with different configurations, right? So different initial value, pulse value, delay time, rise time, fall time, and so on. Right, so these are the simulations, right? You can also find flip-flops, converters, counters, adders, and so on. Right? You can also find the actual SPICE netlist on the left side of the screen, right? By going to the I symbol, right? These are the circuit settings, so we'll save it in a second, and you can find the simulation over here if you want to take a deeper look. And this is the errors and warning page, right? So let's say we're happy with the circuit and we'd like to keep working on it at a later date, right? So what you can do is go here in the top left corner and save it, right? So I can save it as, let's say I want this to be public, and Multisim circuit, right? I can give it a description, I can tag it, and so on. Right? So I click OK. Right, the circuit was saved successfully, and now I can work on it at a later date. Right, so if I go back to the home page, I can find my circuits. Right, so right now I have two other private ones. Right, an RC circuit. This is my page, right, with my circuits. I have two other circuits, and this is the circuit that we have been working on. Right? And I can preview it and then keep working on it. Right, so Multisim Live also has this collaboration aspect, right? So you can share your circuits, or you could, let's say, search for some other circuits. Right? So from here, you could go to public circuits or reference circuits and just take a look and see what other people have done, right? So here you have a buck converter, digital to analog converter, and so on. Right? So you could find whatever you're interested in. Right? You also have reference circuits which are featured. Right, and besides this, you can also, let's say you have a classroom, right? You could create a group, right? So, or maybe search for an already existing group where you could work with your students or maybe your friends on a project, or maybe you'd like to collaborate, right, on something, or keep track of whatever your students have been working on. So you could create a group and then monitor it to see the progress on it, right? You also have the help page, which is basically the documentation for Multisim features, right? So how to create a design, how to simulate it, placing components. You also have the documentation of different simulation types and component documentation, right? So let's say for the 555 timer, I can go on and see different descriptions, right? So for example, on the flip-flop, right, I can see how to configure it, right? So you could, for the D flip-flop, you can configure it to either use a negative edge, right, a rising edge or a falling edge for the clocking side, and also you can change its set and reset values, right? So here on the help page, you can find all sorts of helpful information. So that is pretty much it.
Awesome.
Britt, do you have anything to add?
Yeah, yeah. Thank you, Edward, for taking us through it. We've got a bunch of questions still in the in the question box, but we're basically at time right now. What we will do with these questions is they give us your name on it. So if you're okay with it, we can email you. We'll also send out an FAQ with the answers to a lot of these questions. And a lot of folks have been asking like, hey, how can I download Multisim, or how can I get started? So what's awesome about Multisim Live is that it's not Multisim Desktop. Multisim Desktop is great, but Multisim Live doesn't require any installation or download. You can access it right in the browser. So if you want to get
Yeah.
started on the free tier, or if you want to go and do the standard or premium, all you have to do is use a web browser, go sign up, and you can do most everything that Edward was doing today. Likewise,
Yeah. So
oh, go for it. Go for it, Edward.
yeah, so just go on multisim.com and you can get started.
Yep.
Yeah.
Yep. And then if you guys are looking for like bulk licensing for your universities or anything like that, I'm the right person to talk to. We're currently working on a bulk licensing manager, so you could self-service. But right now everything is handled manually, and it goes through me. And so I'll just talk with you and work with what your needs are and your budget, and we'll figure out how to get Multisim Live into the hands of your students. Likewise, if you guys have any ideas for how we could improve Multisim Live or add features to it, we have a thing called the Digilent Idea Space. And there's a section on it called Multisim Live. This is where you can go and add ideas that you would want to have added to Multisim Live, as well as view other ideas that users have submitted and vote on them and comment on them. We'll also send that out in a link after the webinar. Yeah, with that, thank you guys so much for attending. Edward, thank you so much for walking us through and doing a really thorough job. I really appreciate it. And we'll catch you guys on the next webinar.
Thank you, guys.